This section introduces inventory and order management, which focuses on how organizations manage stock levels and customer orders efficiently. We will understand why inventory control is important for cost reduction, service level improvement, and smooth supply chain flow across warehouses, transport, and customers. Inventory means all goods and materials a company keeps for production or sale. It is both an asset because it helps meet customer demand and a liability because it blocks working capital. There are different types of inventory like raw material, VIP, finished goods, MRO supplies, and transit inventory. For example, in an automobile company, steel is raw material, engine fitting is VIP, and the completed car is finished goods. In inventory management, there are four main types of costs. First is ordering cost, which is the cost of placing and processing an order like admin and transport. Second is carrying cost, which is the cost of storing items such as warehouse rent, interest, and insurance. Third is stockout cost, which happens when items are not available, leading to lost sales or production delays. Fourth is purchase cost, which is simply the cost of buying the product from the supplier. The total inventory cost is the sum of all these four. Total cost equals ordering plus carrying plus purchase plus stockout. The goal of inventory control is to balance these costs and keep total cost as low as possible. This slide explains the main objectives of inventory control. First, we aim to maintain required service levels so customers always get products on time. Second, we try to minimize total inventory cost by balancing ordering, carrying, and stockout costs. Third, we focus on optimizing order quantity and ordering frequency so we don't overstock or understock. Lastly, we work on improving inventory visibility and tracking using systems like ERP and WMS so stock is always accurate and traceable. The main idea is to balance availability, cost, and control. ABC analysis is used to classify inventory based on value and importance. Category A items are few in number but high in value, so they need tight control and frequent monitoring. Category B items are medium value and need moderate control. Category C items are low value but high in quantity, so they are managed with simple controls and bulk ordering. For example, in a spare parts warehouse, engine parts are A, belts are B, and fasteners are C. Siemens used automated ABC analysis and reduced stock levels by 15% without affecting service levels. EOQ helps us decide the best order quantity that minimizes total inventory cost, which means both ordering cost and holding cost. The formula is EOQ equals square root to DSH, where D is annual demand, S is ordering cost per order, and H is holding cost per unit per year. In this example, when annual demand is 10,000 units, ordering cost is 500 and holding cost is 50. The EOQ comes out to 447 units. This means ordering for 147 units at a time gives the lowest total inventory cost. EOQ helps companies avoid both overstocking and too frequent ordering. Reorder point is the stock level at which we should place a new order so that stock doesn't run out during lead time. The formula is ROP equals demand times lead time plus safety stock. In this example, daily demand is 100 units, lead time is 5 days, and safety stock is 100 units. So, ROP equals 105 plus 200 equals 700 units. This means when inventory reaches 700 units, a new order should be placed to avoid stockouts. Safety stock is extra inventory kept as a buffer to protect against demand fluctuations and delivery delays. It helps prevent stockouts when demand suddenly increases or when the supplier delays delivery. The basic relationship is linked with ROP. ROP equals demand times lead time plus safety stock. For calculation, safety stock can be found using SS equals Z times sigma times square root LT, where Z is service level factor, sigma is demand variation, and LT is lead time. In real life, companies like Britannia Industries keep safety stock to manage seasonal demand and supplier uncertainty while maintaining high product availability. This slide explains the different types of demand patterns seen in real businesses. Constant or stable demand. This type has regular and predictable demand like detergents or paper products. Seasonal demand. Demand changes with season like axe in summer and woolens in winter. Trend-based demand. Demand increases or decreases over time like electric vehicle components. Irregular demand. Demand is unpredictable, mainly for project-based or one-time orders. Understanding these demand patterns helps companies improve forecasting accuracy, reduce stockouts, and avoid excess inventory. This slide explains different demand forecasting techniques used by companies. Qualitative methods used when past data is not available. Techniques like Delphi and market research help forecast new product demand. Quantitative time series based on past data patterns. Methods like moving average and exponential smoothing are commonly used for FMCG sales forecasting. Causal methods. These identify relationships between demand and other factors like price or income using regression and econometric models. Case example, Hindustan Unilever, by using AI-based forecasting, Hull improved its SKU forecasting accuracy from 78% to 93% and reduced stockouts by 15%. This shows how advanced forecasting improves inventory planning and customer service. This slide talks about demand segmentation using ABC and XYZ methods. ABC classification is based on value contribution, high-value items. B. Medium-value items. C. Low-value items. XYZ classification is based on demand variability. X. Stable demand. Y. Moderate variation. Z. Highly fluctuating demand. When we combine ABC and XYZ, it helps in better inventory control. For example, X items, high value plus stable demand needs strict control and accurate forecasting. CZ items, low value plus unpredictable demand can be managed with simple or flexible strategies. This slide explains the order to cash out to C process. It starts when a customer places an order and ends when the payment is received. The main steps are order entry, order processing, picking and packing, shipping, invoicing, payment collection, and customer feedback. The goal is to make order processing fast, accurate, and smooth so customers are satisfied and the company gets paid on time. This slide explains why order accuracy and visibility are critical in order management. If the order is correct, customers stay happy and returns reduce. Visibility means customers and internal teams can track the order in real time, which builds trust and transparency. We measure this using order fill rate, perfect order percentage. Order cycle time. Dell is a good example. Their real-time order tracking reduced returns to less than 1%. This slide talks about how technology improves order management. ERP systems like SAP and Oracle connect all order data. OMS handles order processing, while EDI supports B2B orders. AP is connect e-commerce platforms smoothly. For example, Flipkart uses OMS and WMS integration to automatically assign orders to the nearest warehouse, which helps in faster delivery and better customer experience. This slide explains the key metrics to measure inventory and order performance. Inventory turnover shows how well stock is used. DOI tells how many days inventory stays before being sold. Fill rate and stockout rate measure customer service performance. Order cycle time shows how fast we deliver orders. Carrying cost percent shows how much we spend to hold inventory. In Dabra's case, using dashboards helped reduce DOH from 60 to 42 days, improving efficiency.